Thank you for coming to give a talk here on DevOps and continuous security with Kubernetes.
Right, thank you. Right, thank you everyone for coming today. I'm going to talk a little bit about Kubernetes and containers in terms of security and the Ci/CD pipeline. But first off, talk about some of the business drivers as to why you would want to adopt this in your business. Just an example in the automobile industry, traditionally it's a very static and planned process of releasing a new product each year. In the fall, you can predict that there be a new vehicle, new model, and every 5 years or so, maybe a complete revamp of that particular model as well. But it's a very slow innovation, very static and planned. It's really designed for global scale across the world. Ford, for example, can deploy vehicles all over the place with their dealer network and different geographies. Then you have flip side of that is really Tesla, I would say, a very innovative company, and they've totally turned it upside down. No dealer network. They're able to streamline the delivery of their vehicles to their customers, and they're able to rapidly innovate. Right? The vehicle incrementally gets better, and a major reason around that is the frequency of software updates that they're able to deliver to these vehicles over the wire. And it's had a profound impact on the business because no longer is it a single transaction at the dealer lot in terms of purchasing that vehicle, but now they have add-on services, right? They can sell to their customer incremental services to maybe improve the 0 to 60 time, and it doesn't require going into the dealer network. They can deliver that update or addition over the wire. They can improve the battery efficiency to their customers as well. So really transforming the business, just like the phone industry as well, right? The iPhone turning in not just into a device that you buy, but layered services on top of that. And it's very applicable across many different industries. Right, and so IT, a lot of pressure on them to kind of evolve and transform, and that's why you're seeing this adoption of DevOps that enables the rapid frequency of updates of your applications, and that is accomplished through a change in their culture, a change in process, really automating your process of delivering software from dev into production. And then, as you see, most adopters of DevOps are leveraging open source solutions to really automate that process. But what about security, right? Security is typically an afterthought. It doesn't really align typically with moving fast, right? Security is often viewed as a bottleneck. It's viewed as process that I have to go through to get a change request approved, whether it's changing the firewall or changing the load balancer or changing the system. It is slowing down and often forgotten and often ignored, and certainly in these times we can't do that. As the move to DevOps, it's really having an impact in terms of evolving security as well. You see this movement towards microservices of breaking down the application. Now a single application may span across multiple environments. There's an increase of reliance on the network of service-to-service communication. How do you ensure that that is secure and trusted in your environment as well? It's no longer just hiding behind your firewall and your enterprise. Also, you're seeing a movement towards hybrid cloud environments. Most of our customers that we work with, we're seeing they have on-premise as well as one or more public clouds across their enterprise. So how do I have a consistent security process, tooling across these environments? How do I ensure that they're not different process per provider, and exposing that to my developer, right? That's going to slow things down, and ideally I have a single consistent way of doing that across no matter where I need to deploy it for my business, whether it's at the edge, in a retail location, or in the back-end data center, or in the developer's workstation. Also, of course, with the movement to cloud, multi-tenancy. How do I ensure that a business can trust the infrastructure no matter where it gets deployed? No matter whether it's sitting next to a database or a lightweight application, I want to ensure I have quality of service. I want to ensure that that infrastructure is secure. And so that's given rise to really DevSecOps, right? That's inserting security into DevOps. And security starts not in production, but it starts in development, right? And that's really a cultural change, right? You have to prioritize from a business, prioritize from a product or service perspective that security is a priority in the release and the productization. That means secure your coding practices, means continuous security testing, treating everything as code, right? Infrastructure as code. We want to enable that to be repeatable, consistent, auditable, and leveraging automation. So it's consistent, and I can quickly configure and deploy across my infrastructure, no matter where it is. And I'm getting continuous feedback, right? If something's not working, if there's a security vulnerability in an image, I want to have immediate feedback that that's an issue, right? If something is down, I want to know that as well. And I can adapt, pivot, and change, and quickly release and update from dev into production in a matter of minutes rather than days or weeks. Right? So how do you do that at scale? And that's where, no pun intended, but Kubernetes is really a platform to enable not only the management and the deployment orchestration of containers across any provider, physical, virtual, private, or public cloud, but I also see it increasingly as a way to standardize your security no matter where your applications are being deployed, public or private cloud, for instance. Right? I can have a consistent set of tooling, a consistent set of processes and policies across these providers. And that allows me to move fast, right? And to ensure that I have a trusted infrastructure that I expect to be out there. And containers are a big part about moving fast, and they certainly add some benefits from a security perspective. Right? First off, I can have a bare minimum image packaged into my container so it's lightweight, has a reduced attack surface. Right? I don't have to worry about unused components being included in that container image. It also allows me to quickly respond when there is a security issue, because I can quickly go back into development, build that image, and then push it through my standard test cycle, scan it, and put it into production in a matter of minutes, typically, or minimal number of hours. Also, in terms of the quality, right? I build it once, and then I deploy anywhere, right? I'm not rebuilding or reconfiguring that application or service as it moves from dev test into production. The developer builds it, I take what the developer built, I test it as is, and I move it into production. If I need to change that due to a security issue, I go back to development and build another version. And portability, right? Able to take that image, deploy it to dev, test, production, public, private cloud, physical or virtual, so I have consistency. When I have consistency, right, I can improve quality and reduce the risk. And so when it comes to a containerized environment, here are some best practices when it comes to security. One is, there's no one knob to secure everything. It's a layered security approach. There's quite a bit of different layers to this that we'll go through to provide a more and more trusted environment in your enterprise. Also, take the mindset of granting the least privileges that are necessary for your containerized microservice or application. The default typically is wide open, and so make sure that you're locking it down, and we'll talk about how. Also, reduce attack surface. So I mentioned about building an image, just the bare minimal dependencies. Keep that attack surface to a minimum, and build your images with the mindset of them being immutable. They don't change once they're built. Configurations, keep them outside of the container image. Data as well. And so let's go into some best practices. First, talk about containers. You build, you ship, and then you run, right? So when it comes to building, you have a build file, specifies the different components that go into that container image. Once it's built, you can push it into a registry that allows you to share it across dev, test, and production, or on-prem or off-prem, for example. And then I can deploy that image and instantiate it as a container instance running anywhere I have Linux operating system. My container runtime environment allows consistency because of the standardization in this industry around the image format as well as the runtime. When it comes to the image itself, it's a change in terms of a developer, what they ship and provide to their test environment or to their operations team. No longer are you just delivering your jar files, for example, in a Java application, but now they're packaging that into a container image and building it. And what's inside that container image will be the OS dependencies, right? This is the minimal footprint of your base operating system, and then the dependencies for that application from a language runtime, all the libraries or the binaries that it needs to execute. And then the application, the jar file in this case, as well. And then when I build that image, I can tag it, for instance, with a label 1.1, or version 1.2, et cetera. I can have multiple images. And because I have everything I need to run, that means I can have multiple images, multiple versions running side by side on the same host, right? I don't have to worry about how that host is configured. Also, from a security perspective, I know what versions I'll be running against as well. It's not I as the application owner. So those different layers, traditionally, different folks in your organization own those layers today. How does that translate into a container environment? So here you have operations. They can still own the OS. They'll own the base image for the operating system and can provide that as a service to their developers and their application owners. The apps or the database team can own that middle layer, the language runtimes or the database, and then the developer can own the application layer. And so these layers can come together to produce the resulting container image, right? And configurations and storage, of course, would be kept outside of that container. So we talked about treating containers as immutable. That means they don't change. So things that change, configuration or data, that's stored outside of the container image. And in Kubernetes, they provide a way to store configurations in what's called a config map. So think of this, maybe it's an IP address, it's a label identification string that I need for my application, or maybe it's a configuration file for my application. And so that can be defined in a config map that is stored in etcd in the Kubernetes master architecture as a service. If I need to have it encrypted, Kubernetes also has what's called a secret, and I can store that value or that configuration file and have it encrypted. The data I can access via a persistent storage that Kubernetes can provision, or through like a JDBC connection, whether it's a public cloud or on-prem service. Let's take a look at an example of the config map. Maybe I have my JBoss Java application server running, and that requires an XML configuration file. Instead of storing that in my container image, I would actually define that in a text file, save it in my source code repository, version control it, and then when I define my Kubernetes application, the YAML, I would actually specify a config map that maps to this configuration file. Right? Now, when I launch and deploy my service in Kubernetes, it'll take that container image for my Java application, run it as a container instance in my cluster, and at runtime, it will define the config map based on the configuration file that I have saved in my source code repository, Git, for instance. Right, so that's separation of your configurations from the image. And also, just keep in mind, every time you build one of these images, you traditionally would add a label to version control it, easy to use, 1.1, 1.2. But be careful, because you can rebuild and reuse that label. And so when you're out in production, you can't always necessarily trust the label for uniqueness. Right? Instead, you'd have to look at what's called the digest. That has a unique ID for that image. Sometimes we see software vendors, we see development shops reusing labels, and this leads to having multiple versions out in production and trying to debug issues, wondering why things work on one system and not the other in a cluster. What about continuous building? How do I automate this process? So from a security perspective, what we're seeing is sometimes security issues aren't about changing code and inserting something. Sometimes it's about attacking the build environment and injecting a vulnerability at build time. And so a best practice is to version control your build environment. And you can do that by putting your build environment into a container image, versioning it, and then using that to build a particular version of your application. Right? And then that process would output a container image containing your application and then just the bare minimum dependencies at the app and the OS layer. It does not include the build tools. Right? So it's nice and lightweight as well. Now I can go back in time and I know what version of the build environment was used to produce every version of my application. And if I archive that, I have those versions and I can redo that. But I also can inspect if there was a vulnerability inserted into my build environment as well. So best practice, and then also I can reproduce that environment consistently. So a CI/CD pipeline with Kubernetes kind of looks like this. You have your developers checking in their source code, build files, you have your operations team also doing that, you have configuration files, etc. And then it goes to the build process. It'll pull down that build image that we're talking about from your image registry and then build the resulting container image for your application. Builds it once, and then I would deploy that in my dev environment. I would deploy that in my test environment. And then I could also push that into my production environment when it's ready to be deployed. Right? That's the same consistent image across the board. I use a build image to build that container image. And in Kubernetes, I could use namespaces or individual clusters to isolate the different environments, in this case, dev, UAT, and production. But have a registry which allows you to push the images across those environments. Right. Now, once that application is running in production, right, I have those three layers, the base OS image, I have the application dependencies, and I have my application. What if there's a security issue and there's an update to address that? Right? I, as a developer, don't need to be monitoring all three layers. I can just pay attention to my application. And you could actually automate the checking So you could look at the dependencies and then look into the registry if there's an updated version of any of the layers that I depend on, and that could trigger an automated rebuild. So generating a new pipeline, for example, in Jenkins, to build your container image with the new, in this case, let's say there was a OS security vulnerability, there would be a new OS image available in my registry, which would trigger that rebuild, and then make that available to my test and production environments. So cascading rebuilds. Also, container registry and scanning. You know, what's inside the container matters. We talked about a container contains those 3 layers. It pulls in a lot of components. Here you have a C application, Java, Node.js, and a Perl, PHP image. And the little triangle indicates how many security notifications are for the different components that get pulled in. For example, in the second column, the Java application, the JRE, has over 60 security notifications. So not only do I need to be conscious of where I'm pulling these images and what's inside of them when I initially get that image, but I also need to have a process to continually scan and inspect these images to see if there are any new known vulnerabilities, so I can address those. And typically, to ensure that you're pulling your images from a trusted source, the first thing I see most customers in adopting containers is they set up a private registry in their data center so that they have trusted content, but they also can own the life cycle of these images as well, not defer that to a untrusted public provider. And so when you need that old version 6-12 months down the road, I know I still have that in my local registry. And you could have auditing and security in terms of who can upload and modify. In terms of addressing how do I ensure that images consistently going forward don't have security issues or vulnerabilities, I can insert a scanning process into my pipeline. So here's a Jenkins CI pipeline. You have the individual runs, the build, 1, 2, 3 from bottom up. And then you see we inserted a security phase as step 4 of this process. So that will, after the image is built, it will scan that image and identify if there are any security issues. And how would I do that? You could use a variety of different tools to scan your images. One tool that's an open source solution is called OpenSCAP. That allows you to scan the image for known vulnerabilities, so checks based on the RPM versioning. And then secondly, you could scan that to see if it conforms with your security policy. So you can define a security policy, maybe it's the minimum password length, such as this example, and if that image doesn't meet that standard, it will flag it and alert you in one of the reports. It will generate remediation scripts in Ansible, so you can rectify that issue. And then also, you have an audit log as well, in case you need to show that for reporting purposes. So there are a lot of tools out there, but OpenSCAP is one such tool. In Kubernetes, you know, how do you enable and automate your CI/CD pipeline? A lot of early adopters of DevOps and CI/CD pipelines, they customized and wrote with scripts. Now there's a lot of tools out there. Kubernetes certainly enables a lot of automation out of the box that you can take advantage of. And a big difference here, as we've been talking about, is that you build your container image once and you push it all the way through production. And so how do I, when there is a security vulnerability in my production environment, I'm not going to go and patch SSH into my box and patch or upgrade the version out on my production system directly. Traditionally, you may do that today because it takes 2 weeks to push a new version to go from dev into production. But with this highly automated CI/CD pipeline, Right now I can go back to developers and always have them address that with a new version release. And instead of SSHing into my box, I can leverage one of these continuous delivery or continuous deployment mechanisms in Kubernetes. There are different models. I could do a recreate, I can do a rolling update, a blue-green, or for experimentation, I'll do an A/B testing with canaries as a developer. The recreate, that basically is the simplest model. You have version 1 of your service out in production, and to go to version 2 with that new security fix, I just take down version 1, I have some downtime, and I deploy version 2. Very simple. Don't have to interact with the developers. It's very easy in that regard. What if I have requirements to keep the application or service up all the time with zero downtime? Then I might want to look at these other options. One is rolling up. You have 3 instances or 3 pods of your application out in the cluster. It will upgrade each one individually until you get to 100%. And you could stop and roll back at any point. And that allows me to have zero downtime, but it requires my application to be able to handle 2 different versions in production at the same time, right? And so I need to make sure my database schema and my application are aligned for that. Thirdly, the blue-green, right? I have my version 1 out there in my blue environment. It's time to upgrade to version 2 with that new security update. I can just flip the traffic using the selector in a Kubernetes service to route the traffic from version 1 over to version 2, let the version 1 traffic die down, zero downtime. I also can quickly revert back to version 1 because I didn't bring it down in case there's an issue. And so there's a little bit more comfort knowing that I can revert back without any changes, and it continues to be just as I left it. And then lastly, A/B testing. So I'm going to go a little more detail so you see an example of this one. But this is commonly used to accelerate the delivery of updates in Kubernetes. You enable your developers to experiment, try things out. If there's a security issue, they can test out that new version quickly and deploy with confidence before they roll out to everyone in production. So in this example, on the left side, I have version A, and I want to experiment and try out a new recommendation engine for my mobile application. Here you can see it's recommending a few different products on the right side. So this could also include a security update. So my existing version A is out in production. It gets 100% of the traffic. I see the conversion rate is 25%, so I'm getting that continuous feedback. I'm doing that by setting up a service, a Kubernetes service that front ends this version A, and I've defined a selector of demo in version A that routes all the traffic over to version A, and I have a third party tool tracking the conversion rate. There's a security issue, et cetera. I want to try out version B. What I can do is put that through testing. I go ahead and deploy that with the label of app equals demo, version equals B, and I can update the selector so that it starts routing some of the traffic over to version B, right? In this case, it's just I've only deployed 1 pod, whereas version A has 3 pods, so it's going to get 25% of the traffic just based on the number of pods. If you need finer granularity of routing your traffic, that's when you want to look at something like a service mesh, like Istio, where you can do, I want 1%, 2% of my traffic to go to this particular version, right? But this is a simpler model without the additional complexity. And now that I have confidence that security update in version B is working well because it improved the conversion rate as well with that new recommendation engine, I'm going to route all that traffic to version B, and I just add the updated selector with the version B label. And that's all using Kubernetes, right? Another thing I may have to do is quickly move from one database to another database. Right? Maybe it's as I move from dev into production, or I need to move from one version to another version. How do I do that? Maybe I'm addressing a security issue. So in Kubernetes, they provide some ease of use around that. Is on the left, I have a development database, and on the right, I have production with different IP address. And what I can do is I can deploy my web app into Kubernetes as a pod. It'll pull down the image. It's running. And I don't want to hard code that image with an IP address. Right? Otherwise, I would have downtime if I want to change it. And it's just a bad practice. It's not a mutable image either. And so in Kubernetes, what you can do is you can set up a service of cluster IP type and define, in this case, it's the front end of MongoDB. And I want to leverage that service to route traffic to whatever database I want behind there. So initially, I want the red database. And so I define an endpoint for that service with the IP address of the external database. In this case, it's on a cloud, public cloud service that's running outside of Kubernetes. Now, maybe there's a security issue. I need to switch over to the blue one. And instead of bringing down my image or my instance and changing it, I can actually just update the object in Kubernetes, the endpoint, with the blue IP address. Right? So minimize downtime. I can have a static connection string in my image, probably defined as a config map as well, to make it easy to change if I do need to. And that allows me to be able to move fast and address perhaps a security issue at the database level. If you need to use a URI, you could also do that. A lot of cloud services require that. Right. What about addressing a security issue due to maybe a schema change? Right? How could I manage that? Also, a lot of people just ask, how do I do DevOps with databases that are running inside Kubernetes? And this is an example where you have version 1 of the schema in production, version 2 in test, and a subsequent version in development. And I'm going to push those through the pipeline. What you can do is you can use a tool such as Flyway. It's an open source tool to do version schema control. And what you do is you define your schema change, like in your SQL file here, you version control it, and then you create a Flyway container image with that SQL change and the Flyway application, right? And I version it, and I call it, in this case, Flyway MyDB version 2, so version 2 of my schema. Right? This is a very simple model of how to do it. I could use config maps as well. And now that I have that image with Flyway in my database schema version 2 defined, I can then roll that out quickly into Kubernetes. So I have version 1 of my PostgreSQL database running. There's a security issue, requires a schema change. What I do is I run and create a Kubernetes job. So this is a way of deploying and running one container instance one time. In this case, it's going to run the Flyway application. It's going to pull down the Flyway version 2 image. It has the username password to connect to this database over JDBC. Once it starts, it immediately connects to the database, and it has the SQL script that we saw earlier to upgrade the schema to version 2. Right? So typically, if I want to go from version 1 to version 2 of my application, I would first upgrade the schema of my database to make it not only compatible with version 2 of my application, but also version 1, has some backwards compatibility. and then you could drop that, however many N-1 versions you want to maintain backwards compatibility. Okay. And now I have version 2 of my database. So that's updating schema changes quickly that may be associated with a security issue. Now, we talked about a continuous feedback loop. As you move to a containerized environment, you need to be aware of kind of the different tools you have available to see what's going on in your environment. Traditionally, you have access to your host level information, CPU memory, et cetera. And so the node exporter is a tool there. What about the container level, right? So you can get metrics from the kubelet, which is the process that runs on the nodes in the Kubernetes cluster. This is a C advisor, so it provides different metrics about each pod and container what they're consuming. Also, there's metrics for the Kubernetes cluster itself. And then at the microservice level, you're probably going to be looking at, from a development perspective, adopting a service mesh as you get more sophisticated applications so that you can manage at a finer granular level the traffic from service to service, as well as controlling mutual TLS between service to service so that they're trusted. Also, potentially routing traffic from outside in, and also being able to have observability. So using a tool like Jaeger to get visibility into how much traffic is going from one service to another, and then also using Istio or Service Mesh to control that traffic, right? Routing the traffic. If something's not responding, give up after 3 tries. Wait 5 minutes, then try again, rather than bringing down your entire infrastructure. Also, the ability to mirror traffic from production into tests, so I can experiment and try things out. Right, so those are some considerations. Now at the infrastructure level, here's the Kubernetes architecture. And everything in blue really comes with Kubernetes. But in order to run Kubernetes, you need some additional components. Right? You need a Linux operating system on your nodes to run those containers. You need a container runtime as well, right? Like CRI-O. And you need a network and DNS service. You need storage if you want to have persistence. And you need typically a dashboard or management console, monitoring, logging, security, and a registry to store your images. Right? And so some of the best practices from a security perspective around your Kubernetes cluster, just in general, is don't run your container images as root. Right? A lot of new users are not aware that container images run by default as root. You have to specify in that build file a user for it to run as. Otherwise, it just defaults to root. Right? So best practice also is in your cluster, disable containers from running as root. And we'll talk about how that can be done in a minute. Also, limit the Linux capabilities. If you are to run as root, you can pare down what that user has the ability to do on a Linux system. Limit SSH access. Use namespaces for isolating your dev, test, and production environment, or use individual clusters. Define the resource quotas so you don't have a noisy neighbor problem. If you have some sort of attack that could bring down other applications that live side by side. Enable logging so you can have an audit trail. Right? Apply security errata not only to the container image, as we talked about in the CI/CD pipeline, but also to the nodes in the cluster. And then pod security policies, I'll talk about in just a second, audit policies. And if you are to run unprivileged containers, run them as read-only. So a tool like, you can use Podman, for instance, to run as read-only. And we're running a little bit out of time. So I'm going to quickly just show you from an infrastructure perspective. One is in Kubernetes, you can use a pod security policy to restrict and limit what can run on a node in a cluster. So if you don't want to run anything as root, you can define in a pod security policy to be restrictive. And there are a lot of other capabilities. Also, you can enable an audit policy in Kubernetes as well. So you have an audit trail of the different activities, the API requests that are going on in your cluster. And it's important to understand kind of the Kubernetes Api Server is really the heart of Kubernetes. All the requests are going through this API service, and you have HTTPS into the API. You have some authentication. Then they're seeing what authorization that user has. And then there's what's called an admission controller, right? This can mutate request based on your policy, or it could reject a request based on your policy, so it doesn't get sent out to the cluster, right? So pod security policies, audit policies, et cetera, they're all tied in to the Kubernetes API Server and the admission controller. And then lastly, you can also define network policy, right? This allows you to restrict the communication of pods in your cluster across different namespaces or within the namespace, right? If you want to lock that down, define a network policy in your with your application and restrict network traffic. Okay. So we're almost out of time. I just want to talk about some additional areas to explore beyond this. There's some exciting projects that are being layered on top in the Kubernetes ecosystem. Kubernetes is really driving towards being a platform that can run any application, AI/ML, virtual machine, a container base. And so KubeVirt is a project to bring virtual machines to Kubernetes. Also, once you have applications containerized, really the challenge is how do you automate the operations of those services? So I have that same experience I would get from using Salesforce or an Amazon service. Right? I don't have to worry about security updates. I don't have to worry about scaling up or scaling down. Right? An operator is a way to take your manual run book for operating a custom service or a third-party service like MongoDB and automating those day-to-day operations for your team. That way, the expert can define it once. It could be an Ansible or Go, and deployed as an operator on top of Kubernetes, essentially automating that for you from a security perspective adds a lot of value in terms of automating that as well. Serverless. You can have serverless applications using Knative, for instance. We talked about some of the benefits from a security perspective for a service mesh. Istio is one project out there. And then having a CI/CD pipeline defined in a Kubernetes native way, that's where the Tecton project is working on, is automating pipeline in a Kubernetes YAML-friendly way and defining that and having that version controlled and easy to manage when you are leveraging Kubernetes. Right. Okay, well, that's out of time, and I want to thank everyone for attending. Here's my contact info. Feel free to reach out, LinkedIn, my Red Hat email address as well. Also be out in the hallway if you want to discuss anything. I know we're a little bit over, so I'll be shutting down pretty quickly. Thank you so much.